Hello there, Mr. Sutton here, bringing you the Algebra 2 Chapter 11 Quiz Review Solutions on Sequences and Series. For this problem, we're trying to write the first 6 terms of this sequence. So we have f of n equals 4 minus 8n. We basically just have to plug the numbers 1 through 6 into this function and see what it comes out to. So we'll start with 1. So f of 1, that's going to be 4 minus 8 times 1, or just 4 minus 8, so negative 4. Next, f of 2, 4 minus 8 times 2 is 4 minus negative 16, or 4 minus 16, so that's negative 12. F of 3, we've got 4 minus 8 times 3. 4 minus 24 is negative 20. And f of 4, we've got 4 minus 8 times 4. That's 4 minus 32, which is negative 28. And these should be going down by 8s, just the way these are set up here. And then we have f of 5, 4 minus 8 times 5. That's 4 minus 40, negative 36. Finally, f of 6, 4 minus 8 times 6. That's 4 minus 48, which is negative 44. For this problem, we want a rule for the nth term of this arithmetic series. So since we have one of the random terms, we don't have a sub 1. We do have the common difference. We're going to plug these things in and see if we can figure out our first term, and then we'll plug that in with the common difference to get the nth term formula. So let's start with the formula. That's a sub n equals a1 plus d times n minus 1. So we're going to plug in things for everything except a1 so that we can figure that out first. For a sub n, we're going to plug in the value of a sub 12, which is 42. a1 we're still looking for. For d, we've got 4, so plus 4. And then for my n value, I have to use the index of this 42 here, so that would be this 12 right here. So we've got 12 minus 1 there. Well, 12 minus 1 is 11. 4 times 11 is 44, so we have a1 plus 44 over there. And subtracting now to find the value of a1, I've got negative 2 for that. And now I can plug everything back in. So we can write a sub n equals negative 2 plus 4 times n minus 1. I do need to simplify this a little bit, so let me distribute this 4. This is going to be 4n minus 4. And then negative 2 and negative 4 gives me a negative 6. So 4n minus 6 is my final formula for this one. Find the sum of this arithmetic series, which I know because they spelled it out, but also we've got a linear summand in here, so that's also a tip-off. I'm going to use the arithmetic series sum formula. That's n times a1 plus an over 2. So I need to find n, a sub 1, and a sub n. Let's see here. For my n value, I'm going to have, well, since we're starting at 1 for this index and our upper limit of summation is 20, that's 20 terms total. So we have 20 for n. A sub 1 is what I get when I plug in 1, or at least the first index for my summand. So that's going to be 3 times 1 minus 6, which 3 minus 6 gives me negative 3. And then for a sub n, that's the upper limit of summation being plugged in here. So we'll have 3 times 20 minus 6, which is going to give us 60 minus 6 is 54. So putting it all together, I've got a bunch of stuff over 2. I've got specifically 20 times, let's see, and here we've got negative 3 plus 54 all over 2. I could probably do this without a calculator just because I'm kind of lucking out here with the 2 and the 20. 20 divided by 2 is just 10, and negative 3 plus 54 is 51. So this is just 10 times 51, which is 510. But you could use a calculator to check it. For this problem, we're trying to find a rule for the nth term of this geometric sequence. So we are given a term that's not the first term, but we are given the common ratio. So let's start with our geometric sequence general formula here. That would be a sub n equals a sub 1 times r to the n minus 1. And in order to actually fill this thing out, we're going to need this a sub 1 value, which again they didn't give us. So to get that value, we're going to plug in things for a sub n, r, and n. For a sub n, we can use this negative 162. a1 we're trying to get. R we have negative 3. And for n, we're going to use the index that gave us negative 162. So n is going to be this 5 right here. So 5 minus 1. 5 minus 1 is 4. Negative 3 to the 4th power is 81. And then if I divide both sides by 81, I can get an a1 value of negative 2. So we just need to plug that back in. We're going to have negative 2 times negative 3 to the n minus 1. And there's nothing else we need to do on this one. For this one, we're trying to figure out the sum of this geometric sequence. And we know it's a geometric series because, well, they said it was. But also, we have this exponential term in here. So we know that geometric series follow an exponential pattern. So we're going to use our geometric series formula, the finite series formula. So that's going to be S of n, S sub n equals, and then we're going to have a sub 1 times 1 minus r to the n all over 1 minus r. So to make this thing work, we need the first term, the r value, and an n value. The n value in this case is going to be this 10 up here. Since we're starting at 1 and ending in 10, there's 10 items here. For a sub 1, I just need to plug the first, the lower limit of summation, which happens to be 1, into this formula. So 4 times negative 3 to the 1 minus 1. 1 minus 1 is 0. Negative 3 to the 0 is 1. So 4 times 1 gives us 4 for that first term. And then for the r value, that's the thing that I'm raising to the power here. So that's this negative 3 right here. All right, well, plugging all that in, we have, let's see here, we're going to have 4. That's our a1. And then we have 1 minus negative 3 in a parentheses raised to the 10th power. And then all of that over 1 minus negative 3, or you can call this 1 plus 3 if you want. So let me just go ahead and plug this into the calculator. I'm not going to try to do this in my head. Let me make a fraction. On the top we have 4, and then we have 1 minus parentheses negative 3. Raise that to an exponent of 10. And let's close the upper parentheses. Down below now we've got 1 plus 3. And that all gives us a grand total of negative 59,048.